I'm going to be going over a Pivnert or an ideal gas laws problem. So I'm going to do number 11 with you. It says to calculate the pressure in kPa exerted by 0.567 moles of a gas in a 32.5 liter container at 45 degrees Celsius. So since I've already told you that these are ideal gas law problems, I know that that's the equation that I will be using. So it's going to be PV equals nRT, affectionately known as Pivnert. And the next thing I like to do is write down all of my givens. So I know that what I'm going to be trying to calculate is pressure. So pressure is my unknown. And just to note it, I know that I'm going to be looking for pressure in kPa. My moles of gas is 0.567. It doesn't matter what the type of gas is, just how many particles there are, so 0.567 moles of it. The volume is 32.5 liters, and my temperature is at 45.0 degrees Celsius. And again, I'm going to convert that to Kelvin because in all of our gas law equations, we convert into Kelvin. So I'm just going to do that really quickly, and I come out to 318 Kelvin. So those are all my givens. Remember that R is a constant, and you have two values to choose from, either 8.31, and remember that is kPa, times liters over moles times Kelvin, so that is the unit. Or you can use 0.0821, and that one is in atmospheres instead. So those are the two to choose from. So I'm going to plug everything in. My pressure is my unknown. My volume is 32.5 liters. That is equal to my moles times R. Now, this is where you choose which R to use, and since I know that I want my answer to be in kPa, I'm going to use this value right here. So 8.31, and remember this is just a very long unit, not an equation. And my temperature is 318 Kelvin. And so what happens here is that if I multiply across and I solve for P, what ends up happening is all of these units cancel except for kPa, and so then my answer ends up in kilopascals. So I'm going to do all of my work here. So 0.567 times 8.31 times 318 divided by 32.5, and my answer comes out to be 46.1 kilopascals.